Hello everybody. So, today's video, we're going to be talking about partial derivatives. So this is where calculus starts getting a lot more interesting. So up to this point, you've always just been dealing with the basic derivatives of a function, where it's, or df, dx, or dy, dx. But if you always remember, when you were taking the derivative of those only ever one variable inside of your function. What happens if you have multiple? That's where partial derivatives come in. So what is a partial derivative? Well, it's the derivative of a function with respect to one variable while all other variables are held constant. So if you have x and a y inside your function, well, you can take derivative with respect to x, ignoring the y essentially, and treat it as a constant, or vice versa with derivative with respect to y. Now, if you can rewrite your formula as a function of just a singular variable, just take the derivative of that function and you're good to go. Now, here's a little bit of notation. The first half of it shouldn't be too bad. You should basically recognize it. So if you're given your basic function, then you have your partial derivative of f with respect to x, and then you also have your partial derivative of f with respect to y. Those are your two different partial derivatives. So you notice instead of a d, it's using a del. Slight difference. Now, the other notation is you'll use f sub x. This will also mean the same thing as the del notation. So f sub x is the same thing as the partial of f with respect to x, and vice versa with y. You have to keep that in mind. Now, of course, they're a derivative, so there's an algebraic definition as well. So you have to take a look at the limit as h approaches 0 of f of x plus h and y minus f of xy over h. Notice how the h is only getting added to the x. The y doesn't have anything changing on it. And that's for the partial with respect to x. With respect to y, guess what? The y is the one that gets the h. So there's your basic introduction to a partial derivative. We're going to get a lot more in depth, including higher powers of derivatives in class. See you then.